All right, good morning, everyone. It's week 3, day 2. We are working on a new algorithm this morning. It's called 3-number sum. But before we get to the algorithm problem, we have to understand a couple new JavaScript concepts before. So we're going to do a bit of research in addition to some problem solving this morning. Okay, so we have a mixed bag. So let's go over some concepts. First, we have sorting using JavaScript's inbuilt sort function. So how does .sort work? How does it work? So let's take this string here, and we call this string array, and it's an array of strings. You see that there? Now I'm going to console log this array of strings using .sort. So we see the strings have apple, orange, banana. And if I console log the array, string array .sort, what do we get? Let's see. We get apple, banana, orange. So what did it do there?
Change the order.
Alphabetical order?
Changed it to alphabetical order. Right. Exactly. So let's continue. Now we have this array, array 1. And in this array, we have 1, 30, 4, 21, and 100,000. So if we apply array.sort to this, what do we expect to see now?
Alphabetical order.
Mathematical order. Let's check it out.
Least to greatest.
Numerical order. We get 1, 100,000, 21, 30, and 4. What the heck is going on there? Why did it not give us the same sort of result that we saw working for the alphabetical order of strings?
Goes by starting numerical order.
Is it a function that's only 4 strings?
Well, no. And that's what we're going to get to. Before we get to that, though, we have to understand how it's working right now, currently. So what's the order? Is there any logic here that we're seeing?
It's the first number of each integer.
Yeah, but it's what Mark said. It's like an alphanumeric order. So it's treating each number like a string, and it's looking at the first integer of each number, and it's using that to sort it, as if the numbers were like words in a sense. You see that there? Does everyone see how it's 1, 100,000, and 21? The next first integer of each number is higher. Okay, so that's what the sort function, that's how it would work on a numeric array. So let's take this understanding and move on to the next part. All right, we need to understand this to move on to the next part. So let's take a poll. How well we understand what sort is doing so far? Okay. Looks like most of us are here. Okay. You're with me? All right. Now let's pivot for a second and introduce something else. I'm going to introduce the concept of an arrow function. Okay, I'm not going to go full in depth of this lesson about the arrow function, but I want you to see it and recognize it now. You don't have to fully understand, but recognize it and see how it works, see what it's doing. Okay, it's not like a full-blown lecture about arrow functions. We're just going to decipher it for the first time. Okay, So let's read here. An arrow function is a concise way to write a function in JavaScript. So that's what it's doing. It's making the writing of a function more concise. It is a compact alternative to a traditional function expression, which with some semantic differences and deliberate limitations in usage. In a brief summary of how to use arrow functions, it is different than normal functions in these ways. An arrow function, they're always unnamed, but can be assigned to a variable that has a name. Okay, so they're not functions like what we write them, function and then name and then parentheses, then curly bracket. They are unnamed, but can be assigned to a variable that has a name. The arrow functions cannot be used as constructors. Okay, don't worry about what that means yet. Okay, the keyword behaves differently in arrow functions compared to regular functions. This works differently in arrow functions. In arrow functions, this always represents the object defined. So this has to do with scope. Okay, scope is its own subject topic lesson in JavaScript. You guys will have to learn it a little bit more as you progress, and you'll be doing algos for the rest of the boot camp. So don't worry about understanding what this is. I just want us to understand a little bit about what an arrow function is, how it's different in that it's not named, but it's basically the same thing. It does a function. And so where our first encounter with an arrow function will be something like this. See this here? Equal sign, greater than sign. So let me pull up a MDN docs to show you an arrow function. See this here? This is signifying a function that is going to follow afterward. Okay, so you can look into arrow functions a little bit on your own, figure out how it works. See this, it's a shorter way of writing a function. Here, it's taking two parameters, function, and then this is the do something section. It's not even closed off by those brackets, as you can see. It's just almost naked, right? So this is a function. This is an arrow function. Okay. So let's continue to now back to sorting. All right. Before we go to that, I just want to see how we feel about just understanding the bare minimum of an arrow function, that it looks different, but it's a function and it does something. It's just a shorter way now of writing the function. Before we were writing it like this, right? Function and then name here. For example, we would say function and then name and then this, and this is what the normal way of a function that you're used to understanding. Now it can be reduced to this. Okay, it can be shortened down. Don't need to use them yet. Okay, don't use them. Just be aware of what they are until we give a more formal introduction. Okay, it's a little weird, but yes, you can write a function in even simpler terms than the way that we've been writing it. So let's continue. We need to now know the difference between using array.sort. Oops, just dragging everything. Array.sort and array.sort A, B, and then it takes in two parameters, A and B, and then here's the function A minus B. So there's a way to write a sort function different than just using the sort function like this, array.sort, like we used on the alpha numeric when we use it on the array of numbers and we got the alphanumeric result. Okay, so let's see how this works now. I have an array of 1, 34, 21,000, 100,000, and -5. Now if I use array.sort on this, let's see, we're going back to the old way of sort. Okay, this is nothing new. So let's see the result just to get refreshed. Here we have -5, 1, 100,000, 21, 30. So about the same result, right? Now we're just introducing negatives. We see that negatives will appear before positives. The difference now is if we use this sort of sort function using this arrow function within it, taking an a, b, that's subtracting a minus b, let's see what it does. Let's see what it does. So I'm going to take this one here. Let's clear my console and run it. Now we get what we're accustomed to sorting numbers, right? -5, 1, 4, 21, 30, 100,000. Okay, do we see? We don't understand. We don't have to understand how it works. Okay, that's what you guys are going to find out for yourselves in your groups. Okay, after you figure out the algorithm, then you can do some research onto how this works. And if your group is able to get that far, I'd like you to present. Okay, so we see now that this sort of sort function works different than a bare minimum sort function that has just array.sort. Somehow now, if we stick in this AB arrow function A minus B within this sort, we'll get this result that we're used to here. Okay, so something is different now about writing this sort function in this way that we get this result. All right, so you don't have to know how it works exactly to solve today's algorithm problem, but you just have to know so far this what it is and what it does. Okay, it works different than this sort of sort. When you have a, b arrow function, a minus b, it can recognize to sort it in the numeric order from least to greatest. Okay. How well do we understand how this sort of sort function with the a, b arrow function a minus b? Do we see how it is different in sorting than a regular sort function? Okay, we see how it's different. Now, time for the algorithm. Having all that information understood, or loosely understood, at least, we're going to solve for this algorithm today. It's called 3-number sum. Yesterday we did 2-number sum. Today we're doing 3-number sum. All right, and here's what the problem is. I'll read it here. Write a function that takes in a non-empty array of distinct integers. So same type of array that we saw yesterday, a non-empty array of distinct integers, and an integer representing a target sum. So same thing as yesterday. The function should find all triplets in an array. Now this is different. We're not finding one pair of sum. We're finding all the triplets in the array that sum up to the target sum. Now this is a bit of a challenge this morning, okay? This is some heavy lifting, but we're here to, get in shape. This is a boot camp, all right? So we're going to find all the triplets in the array that sum up to the target sum. Sum up to the target sum. So you're given an array, every possible triplet now is going to be we're going to find to the target sum. All right, so we'll make the algorithm level a little easier tomorrow. We'll decrease the load, but today we're going to do this 3-number sum and return a 2-dimensional array of these triplets. So we're returning a nested array. Okay, nested. How do I spell it? 2D array. Array within an array. Oh, I have examples below. Why am I writing this? Okay, we're returning a 2D array of triplets. These numbers in each triplet should be ordered in ascending order, and the triplets themselves should be ordered in ascending order with respect to the numbers they hold. If no three numbers sum up to the target sum, okay, if there are no triplets in the array that add up to the target sum, the function should return no three numbers sum up to the target sum. So you should have a function that returns no three numbers that add up to the target sum if there are no triplets that add up to the sum. Okay, so for example, this array here has 12, 3, 1, 2, -6, 5, -8, and 6. And our target sum is 0. How many triplets, groups of 3, combinations of groups of 3 can we get that add up to 0? The output then should be like this. We have these 3 distinct triplets. We have -8, 2, and 6. That will add up to 0, right? -8 plus 2 is -6 plus 6 is 0. So that would be one triplet that equals 0. -8, 3, and 5. So that would be 0, right? Because -8 and 3 is -5. Plus 5 is 0. -6, 1, and 5. That will add up to 0. Because -6 plus 1 is -5 plus 5 is 0. Okay. Now, I'm going to take a poll. How well do we understand what the problem is asking us to do? What is the problem asking us to do? How should we output the result? Right? We're finding all the possible combination of triplets that would add up to the target sum. A little different than yesterday. Here we're seeing the values instead of the indices. Okay. Now, I'll give you guys a hint here in order to solve this problem. In order to solve for it, you have to sort this array and then work on that sorted array. Loop through that sorted array. However you loop through this array, however you work through it, whether you use a for loop to read through it and do the math that way, have variables to hold and do the math. Okay. Before you go and do that, you need to work with a sorted array. So we're going to want to use that sort function that we introduced this morning to sort this array. And then after it's sorted, work from there. Okay.
And you don't want us to use basically your arrow function sort method.
Yes, use that one.
Okay.
Use that one. Yeah. And now you're familiar with it. You see how it works, how it's a little different. You don't have to know, the intricate details of how it works. You just know that it works. If you finish this algo problem this morning, if somehow you finish and you have some spare time, I'd like you and your group, after T-diagramming the function, to do a little research to explain how this sort function works different than this sort function. How the one with a, b, a minus b, how it works different than this sort function. Okay. So help the rest of the class by explaining the difference if you solve for the algo and have some time left over to T-diagram after you've done that. Okay. So that's the order of things I want us to do. I will post the code in Discord right now. And I'm going to then now distribute you guys into groups. Any questions, anybody? Oh, I got to break up my message into pieces. Sorry about that. It's going to be 2 posts on Discord. Get both of them. Okay. So if there's no questions, I'll pause the recording and I'll break this out into groups. Be on the lookout on Discord for the problem. I have to break it up into pieces. So I'll do that after I break up the groups.